Hi there. I want to talk to you about two-point perspective. But before we go over these, I want to just remind you of one-point perspective. So let's look at that first. If you remember when we did one-point perspective, there is only one point. Verticals remain vertical and horizontals remain horizontal. So everything looks like a rectangle if you're looking directly at it. And anything else that is going back into space is called an orthogonal line, and your orthogonals are all receding towards your perspective point. In one-point perspective, your perspective point is on the page at your eye level line, and your line of vision must be perpendicular to the front of the object. That means that if you had laser beams shooting out of your eyes, they would hit a flat surface that is in front of you. It cannot be at an angle. Okay? So, two-point perspective. Now we have 2 points. Your verticals remain vertical, but there are no horizontal lines. This is a lie. I will explain in a minute. So all non-vertical lines must recede into space towards your perspective points, either one or the other of them. Your perspective points in two-point perspective have to be off of the page. One is to the left and one is to the right. They both have to be at your eye level or on your horizon line. And you must be facing a corner this time. So we cannot be facing a flat surface. Okay, so let me show you what this looks like with a box. The hardest part about this was finding a tiny box, and then I remembered the headphones box. Okay, so in two-point perspective, we cannot face a flat surface. Okay, so remember in one-point perspective, we sort of did this, and we could figure out where we are, but it's always sort of a rectangle on the front, right? In two-point perspective, you have to be facing a corner. You do not have to be facing exactly on the corner, so that it does not have to be exact. It can be here, it can be here. Anything in this range is all considered two-point perspective, okay? So right off, the first thing you notice is that you see the vertical line, and then there are no horizontal lines, right? So these two go back at an angle in this direction, and these two go back at an angle in this direction. And objects that we have directly at our eye level, so that if your horizon line is sort of bisecting this vertical line somewhere, you'll notice that you neither see the top nor the bottom, right? But as I scoot this down and it gets lower than our horizon line, then you start to see the top, right? So you see three sides. And then if you scoot it up, you see the bottom but not the top, right? So it doesn't sort of matter where you put this in your field. It's always going to work in two-point perspective. Okay? Now, in two-point perspective, I have this set up on this cool board. I've taught this for years, and I've shown people how to do this on paper, and until I saw this contraption on the internet, I think I wasn't understanding how people were learning it. So let me back this camera up so that you can see what we're looking at here. I have a piece of masonite with an elastic on it, right? So, and I have the elastic pulled tightly. So when I say that our perspective points are not on the page, imagine that the wipe-off board is my page. My perspective points are actually drilled holes, and I have my elastic cord going through the holes. Now, do you need this for doing a drawing? No, absolutely not. You do not. But what's nice about this for teaching is that you can see how the 2 points are related. And I think that that's what I was not being real clear about in the past. Okay, so first thing I'm going to do, if I'm drawing a box, and I can draw the box as though it is, right across from me like this, right? So if I want to draw it equidistant from my 2 points and right in the middle, I can make a vertical, okay? Then I can push this up until I can trace where I want the top of the box, and I can pull it down and see where I want the bottom of the box, and then I can do the same for the other side. Now you can just pull it directly from the corner, but my big fat finger's in the way, and then I won't be able to show you what I'm doing. So okay, so this is an outside corner, meaning that I've walked up to this box and I am looking at it, and it is taller than me, so I'm looking up at the top and down at the bottom of it. So at the top you're seeing a shape that's sort of an A, and at the bottom you're seeing a V. Okay? And this goes all the way over to our perspective point, and this one goes all the way over to our perspective point. Okay? So that's how you draw a box that's directly across from you. Let me draw a few more boxes. What if the box is above our line of vision, right? Or I'm sorry, our horizon line, and over to the right a little bit. So we draw a vertical, and then we can draw our orthogonals going down to the left, and we can show them going down to the right. Man, I'm not very good at this side, my hand being in the way. Find out quick what you're good at on a video. Okay, so I can pull that one, and I can pull this one. Now, when I hold this exactly in the center, if I just shove it up right here, you'll see that it matches, right? So that it matches. The left and the right work together to get that point in the right place. The left and the right work together to get this point in the right place. Does that make sense? Okay, so that's how you draw a box. Okay, so I've drawn a few more boxes here to show you a few things. So I want you to notice that all of the fronts of them, they all have a corner that you're facing, right? If it is below your horizon line, then you can see the top of it, and if it is above your horizon line, you can see the bottom of it. But wait a minute. So remember when this said this is a lie, there are no horizontals? There is exactly one place where there can be a horizontal. So I'm going to move this just so you can see it. If you'll notice, this looks like a continuous line, even though it's not. It is two orthogonals. One is going towards the left, one is going towards the right, but they just happen to line up right along your horizon line. And so things that are exactly at your height will look like a straight line. So if you look at the top of your desk surface, it looks like a rectangle, right? But if you scoot down, if you get out of your chair and look across your desk surface and flatten it until it looks like a line, that is your horizon line being exactly the same height as the top of your desk. This is exactly the same thing. Okay? So there you have boxes in two-point perspective.